question 3, it simply says simplify. You see this term a lot in algebra, and simply it means that you will reduce either the number of terms, fewer terms, or reduce a fractional algebraic fraction down to its lowest form. So if we have one like a, back to my pen, which is 8a over 2b, 8a over 2b, would look for the common factors. So the 2 goes into itself once, 2 goes into that 4 times. So I'm left with for a over b. I can't reduce that down any further. And if I look at j, j is 6rt over 8r, 6rt over 8r. So the common factors, obviously, 2 is going to go into that 3 times, and 2 is going to go into that 4 times. Now there is a common factor of r, so that's going to go out. So I'm left with that equals 3t over 4. That's pretty straightforward there in question 3. And if we do the last one in question 3, which is, back to my pen, it's 4MNP, 4MNP over 24MN, 24MN. So what would be the common factors here? Obviously, excuse me, 4 will go into itself once, and it'll go into 24 6 times. M will go into itself once, and then N will go into itself once. What I'm left with is then 4 times 1 times 1 times 1 times P. So that's P. I'm left with P. And on the bottom line, everything's gone out. M and N have gone out, and I'm left with 6. So that's P over 6. So 4MNP divided by or over 24MN leaves me with P over 6. Looking at question 4, part A, again we see simplify, which refers to all of them. So we've got a squared divided by a, so that gives us a 2 minus 1. So that leaves us with a, 1a. So that equals a. So I've got a there. A goes into itself once, and it goes into a times, a squared, a times, because a squared, a times a equals a squared. So a squared divided by a is going to be a2 minus 1. It leaves me with 1a. So the b's cancel out, go 1. So all I'm left with is a. In D, obviously, part D, 3 is going to go into itself once, and it's going to go into 9 3 times. K go into itself once, K will go into itself once. And then M squared, that is M2 minus 1, leaves me with M. So M goes into itself once, and it goes in M times. So what I'm left with is m over 3. Because if I multiply 1 by 1, it's m when I don't write the coefficient 1 in algebra. Looking at part L, 7 will cancel out with itself once, and then A will cancel out with itself once, and then I've got B over B squared, so that's B1 minus 2, and then I've got C squared minus 1, so I'm left with B here on the bottom, and I'm left with C on the top. That cancels out, so what I've got is C over B. I have got C over B. There we go. In question 5, you've just asked to copy and complete that. It's fairly straightforward. 8 to the 6 divided by 8 to the 4 in part A, and then you lay out your A times A times A times A, and then you see that, and you are left with A squared over 1, because you've crossed out 4 A's on the top and all the A's on the bottom. So that just leaves you with A squared. Then in part B, you've got m to the 5th divided by m squared, and you expand it all out on top, right? So you've crossed out 2 on the bottom and you've crossed out 2 on the top. So that leaves you with your m to the 5 minus 2, which is m to the 3rd over 1, which leaves you with m cubed, or m to the power of 3. Then question 6 says, look at your answers to question 5. Can you see a shortcut that can be used? Explain. This shortcut is known as one of the index laws. So the index law, second index law, said it before. Second index law deals with division of powers, right? Division of powers. Division of powers. Keep the base, subtract the powers. Keep the base, subtract the powers. Keep the base and subtract the powers. That's the second index law. Now you need to put things like that with examples of it in your summary book, because you're able to use a summary book. Your index laws, 4 major ones we'll deal with, but really yes, it could be as many as 7, but we're going to deal with the first one, and then there'll be another one which is a number or a pronumeral to the power of 0. We'll deal with that one, how it always equals 1. Question 7 really is just a working of those index laws, or the second index law, when we keep the base and subtract the powers when dividing. So p to the 10th divided by p to the 7th becomes p to the 10th minus 3, minus 7, I should say. I'm getting ahead of myself. And
good afternoon, staff and students.
Equals
just a couple of announcements before lunchtime
p to the
today.
3rd, and I'd better put that on quiet. Okay, while that announcement was on, I just did C and F. So what we've got is n to the 14th minus n to the 11th, 14 minus 11 is n to the 3rd. With part F, 6m to the 8th divided by m squared, it's obviously 8 minus 2, and it becomes 6m to the 6th. There's nothing to take out the 6 with. So then in question 8, it asks you in a few sentences, explain how and when the index law for dividing terms is used. And it is for when you are dividing powers which have the same base, you keep the base and subtract the powers, because division is the inverse of multiplying, which we did in 4D, and therefore subtraction is the inverse of addition. we are looking at doing that. That's pretty straightforward. Then question 9 is simplify a to the third divided by a to the third. Let's have a look at that. Question 9. A to the third divided by a to the third. And this leads us to another index law. So we'll do a times a times a over a times a times a. Now when you cancel them all out, 1, 1, 1, 1, you're left with 1 times 1 times 1 over 1 times 1 times 1. But what you've had is a to the third minus 3, that's a to the 0, a to the power of 0. So what we've got is, for any number or any pronumeral, any term raised to the power of 0 equals 1. So a to the power of 0 equals 1. Which leads us to the index law, any term to the power of 0 equals 1. Any number, any term, anything at all to the power of 0 equals 1. So you're not doing 3 minus 3 as in you're left with 0. In the traditional sense, you're actually cancelling them down. As I've done here, you cancel them down, and that brings you to 1. 1 times 1 times 1 times 1 times 1, divided by 1 times 1 times 1. So you have the situation where you are going to get any number or any term to the power of 0 equals 1. So in question 10, part A, when you simplify it, you're going to do this. X to the 5 divided by x to the 5. X to the 5th divided by x to the 5th. Remember, we said that in fact what it looks like is this. It's x to the 5th, because algebraic division is written like this, over x to the 5th. And that is written as x times x times x times x times x. 1, 2, 3, 4, 5. So that's over x times x times x times x times x. So they all cancel each other out. 1. So we're left with 1 over 1, which equals 1. Therefore, x to the 5th divided by x to the 5th equals x to the 0, x to the power of 0, because we keep the base and subtract the powers. Therefore, x to the power of 0 equals 1. Any number, any term, any pronumeral at all to the power of 0 equals 1.